Hello class, this is a video tutorial continuing on using and calculating scientific notation. In this video, we'll be looking at a scenario that involves all of these astronomical figures in order to answer these 4 questions. So let's go straight into it. So question 1, it says, calculate the distance light travels in 1 year. Answer in kilometers. Well, as we can see, we have a speed of light here, 2.99 times 10 to the power of 8 meters per second. So first, since we want this in kilometers, let's convert that into kilometers. So it was 2.99 times 10 to the power of 8 meters per second. Now consider if, like for smaller numbers, when we convert meters into kilometers, it's actually a very simple conversion. If we say we have 2,000 meters, that becomes 2 kilometers. The conversion of that was a simple divide by 1,000. So if we want to convert this meters per second into kilometers per second, we just divide the same thing by 1,000. But to make this calculation easier, rather than write 1,000 as 3 zeros, it'll be divide by 10 to the power of 3. We do this because now we can very easily use index laws to simply subtract 8 by 3. So this will become 2.99 times 10 to the power of 5 kilometers per second. And so now we can start multiplying this value until we convert seconds into a year. So 2.99 times 10 to the power of 5 kilometers per second. If we now multiply this amount by 60 seconds make a minute, times by 60 again, that gives us the hour, times 24 hours gets us a day, and then times 365 gets us the full year. So let's calculate that. So there it is, 2.99 times 60 times 60 times 24 times 365. It actually becomes 94292,640 times 10 to the power of 5 kilometers per year. But notice that this is not in proper scientific notation. To do that, the decimal place, which is currently here, needs to be moved so that it is in between the first and second significant figure. And on top of that, since we have so many decimals, rounding this off to 3 decimal places, the 2 will become a 3. So let's look at this now. This will become 9.43. And consider how many spaces is it has moved. So 1, 2, 3, 4, 5, 6, 7. So we are adding on 7 more decimal places to what is already here. So the 5 adding on 7 becomes 10 to the power of 12. And that is the distance of light traveling in a year. 9.43 times 10 to the power of 12 kilometers per year. And this is actually referred to as 1 light year. Okay, so there we go. Let's move on to the next question. It says, let's calculate the time taken for light from the sun to reach Pluto. Answer in hours. Oops, sorry, I forgot to change this one. This one should definitely be from the sun to Pluto. Just looking at this value now. So we need to use this one here, the closest distance from the sun to Pluto, and this one here. So take a look. Well, notice how we need to figure out how many of these fit into here? Well, the first thing we need to do, since one's in kilometers and one's in meters, we can't operate on these just yet. We need to make sure that both of these are the same unit of measurement. Thankfully, in the previous one, we have the speed of light in kilometers. So let's take a look. It's going to be 5.9 times 10 to the power of 9 kilometers. And now for each of these that fit inside here gives us 1 second. So we're going to divide this by 2.99 times 10 to the power of 5 kilometers per second. And the answer we get here will give us the number of seconds. So we can do this simply by using the decimals and using index laws for these ones. So take a look. It's times 10 to the power of 9 divided by 10 to the power of 4. By index laws, that gets us 10 to the power of 9 take away 5, which is 4. We can now simply calculate the two decimals in the front, so 5.9 divide 2.99. That gets us 1.97. Okay, I'm just rounding that off to 3 significant figures. Now this is the number of seconds. So it's 1.97 times 10 to the power of 4 seconds. Well, the question is asking us in hours. So if we divide this by 60, that will give us minutes. But then if we divide by 60 again, that will give us the hours. So let's calculate that one. So 1.97 divide 60, and we get 0.000547 recurring times 10 to the power of 4. Oh, sorry, that will now be in hours. But look, by applying this index law, since we're going to multiply it, we're going to move this decimal place 4 spaces to the right. So 1, 2, 3, 4. This gets us 5.472 hours. So light from the sun to Pluto takes about 5.472 hours, or approximately 5.5 hours. So there we have it. So this is just the first 2 questions. I'm going to cut the video here. I'll see you in the next video where we tackle these next 2. Hope to see you then, and best of luck.